All right, so one kind of cool, slightly random question that electrochemistry can answer is why don't we store acids in metal containers? So if you ever see acids, they're generally placed in plastics and not metal containers, while other chemicals can be stored in metal containers. So why? So remember that an acid is kind of an H plus donor, or that we have H plus. And think back to our standard kind of electrodes here. The potential of that is 0, right? So 2H plus 2 electrons will give us H2, and this is equal to 0 volts. And then let's take a look at a metal that is often used for storage. So that would be something like aluminum, right? Aluminum's pretty cheap, pretty lightweight metal that can be used to store things or just make any kind of container. And you can see its potential is negative 1.66. And so remember, electrons are negative. They're going to go towards the more positive number. And so the electron is going to flow from the aluminum to the hydrogen. So this reaction is actually going this way. And so if you write the overall reaction and balance it all out, you'll have 2 aluminum solids plus 6 H pluses forming 2 aluminum 3 pluses, which is an aqueous solution, and 3 hydrogen gases, right? And so why don't we store acids in containers? The acid will dissolve the metal away. Now, is that true of all metals? Let's take a look. Remember, the acids have a cell potential of 0. And so actually, that's not true for all metals. If we pick anything above here, this reaction will not be spontaneous. So maybe something like this copper. Where's the copper 2 plus this electron? Yeah, right here, my bad. This copper right here, copper 2 plus and copper solid. So if we pick that, it shouldn't occur. Let's check it out. Right, so in this case, the electron would flow from the top to the bottom, so this reaction would be reversed. Chances are you're not actually going to have hydrogen gas, and so basically this reaction would just not occur. And so copper would be an okay thing to use to store it. We still don't use copper. We use plastic because plastic's cheaper and lighter. And then the other thing that you have to kind of be careful about is one other acid. And let's go ahead and find it on this table. Right here, we have nitrate plus acid, right? That's nitric acid. So that's actually can basically dissolve almost all metals. I mean, I guess you could use gold if you wanted to store it, but that kind of seems like a waste. You can see it'll dissolve away copper, iron, all kinds of stuff, silver, all this stuff. It'll dissolve it all away. So that's because nitric acid is a source of H plus, and the nitrate ion is actually pretty strongly oxidizing, right? And you can see as we get up here, we get a stronger and stronger oxidizing agent.